Okay, I guess we should probably get started so we have enough time left over for the Q&A, and we got some, get into our topic. We have some really interesting stuff for you folks today. It's, I think the people that didn't show up are going to be missing out on a lot of really cool stuff. A lot of lip service and a lot of talk and so forth has already occurred already within the forum, talking about the digital transformation and basically focusing on so far the culture of it, the process within the company, the people that are involved and so on, and the process of what makes a successful digital transformation. We're going to take a really complete departure, well, not a complete departure, but we're going to follow on and really get down into the weeds and talk about, hey, this is the technology that's actually going to be driving some of this stuff. And one of the areas that's going to be affected the most right off the bat, other than just communicating across the internet, is manufacturing. And the science and the technology is going to be driving the new processes, the new products, and where we're going to be going into the 21st century. So that's the basic premise, and that's what I want to cover here. So I'm going to do a quick overview, kind of to lay the groundwork here, and followed by my speakers. And I'm going to touch on some of these technologies that I think will be actually doing the transforming within the context of the digital transformation, because we're going to try to deal with where the rubber meets the road here, so to speak. Okay, is this thing going? Oops. You got the right setup? Oh, here we go. So 2 years ago at the forum, I did a presentation and we did a session on what we called the manufacturing for the future. And this was a slide that was from that presentation and from that session. And what we wanted to do was we wanted to look at the emerging technologies that were going to drive this next generation of manufacturing. So there was a number of things that we focused on there. Of course, obviously, big data, analytics, machine learning, operational intelligence, all these things that are being talked about right now. We were looking at that as leading the way. We were looking at advanced robotics and intelligent automation. We were looking at the introduction of this whole the concept of this whole physical cyber production systems, the digital thread, and so on, which we're still talking about. And of course, the IoT and the connected assets and the digital twin, and all the things that involved all the technologies around that and how that was going to change manufacturing, and the new business models that were going to emerge, the service business models that were going to emerge from the digital twin. What I want to do now is focus on two specific areas. Which way is this thing going? Help? Can you just advance the slides? This doesn't seem to be working. Sorry. Okay, back. Yeah, no, I wasn't done with it. Okay, we're going to focus on two areas specifically that came out of that first look at what we would call advanced manufacturing or technology for the future. Next generation materials and this whole notion of material science and so forth. And we looked at a couple of things back then. And additive manufacturing. Okay, next slide. So what really defined these areas that were emerging was the new science around it and the emerging technologies that will define the new manufacturing. And the science itself is going to be one of the main drivers of where we're going and new manufacturing. Science is changing the materials the products are made of, the manufacturing processes that make them. The new frontier, if you will, going forward is going to be the physical sciences, where physics, chemistry, material science, biology, and mathematical simulation all come together to design the product, to define the processes, and to build the products, based on a completely different paradigm of new materials and processes. This is where the fields like nanotechnology, biotechnology, and material science actually reside. So additive manufacturing and material science development is what I'm focusing on here, will be the game changers moving into the manufacturing of the 21st century. An example would be chemistry. What you have there is an actual 3D model, a simulation of chemistry at the molecular level for designing a battery, for coming up with a new compound. A new compound for battery technology. What you have at the bottom there is a large-scale additive manufacturing printing platform that can print an entire car body in one process. Next slide. What there's going to be a whole range of next generation materials that are going to change manufacturing. It's going to change the industries themselves. We're going to see the emergence of bioplastics, light, flexible materials based on nature itself, based on things like the structure of bird bones and exoskeletons and so forth, that they're already, the aircraft designers like Boeing and Airbus are already doing this, already designing. The next generation of airframe structure, there's going to be lighter and stronger. And the big caveat to all this is that these things, the only way they can make these things is by printing them. We're going to have cheaper, lighter carbon fiber, next generation composite materials. We've already got composite airplanes, the latest generations, but they're going to be more advanced as we move forward. We're going to have things like thermo-electric materials that convert waste into heat. And you're going to see all this kind of stuff in the factories and electric vehicles, and I'm going to touch on that a bit. We're especially seeing the emergence of new materials for battery technology and the simulation of new compounds at the molecular and the quantum levels. We're seeing things like mega magnets, rare earths materials, for the next generation of new lighter, stronger weight to ratio motors, electric motors, which will be one of the major drivers going forward in the new industries. And I'm going to get into that. Next slide. Additive manufacturing is the other big component of this. Additive manufacturing has already moved to the mainstream. Aerospace, automotive, machinery, heavy equipment, oil and gas, all these industries have already started to adopt additive manufacturing for production parts. The oil and gas folks can actually produce through additive processes, say a new drill bit in the field with portable processes. Hybrid machine tools that are a combination of both subtractive and additive processes that you can still use the very close tolerance machining abilities of subtractive processes in conjunction with the additive process and come up with some really different parts and some parts that can only be built by additive. So the basis of this is that AM can produce complex parts that would be impossible to manufacture using our conventional processes of subtractive manufacturing today. Next slide. So I'm going to take a little jump here and talk about a market, an emerging market, that is going to take full advantage of these new science and technology for manufacturing, and that's the electric vehicle market. And just to give you some statistics and give you an idea of where this is at right now, in 2018, we had 3.5 million estimated worldwide EV stock. That was up from 2,600 or 2,700 or so in 2007. 9% more than just in 2016. 40% of all the EVs are in China today, with a 72% projected growth. The little country of Norway, 40% of all new car sales in Norway today are EVs. Norway is going to go all electric transportation probably within 5 years. Volvo has already said that they're not going to produce internal combustion engines anymore. So we're seeing sea changes as we speak. And today, 25% of that EV stock is right here in the US. It's third after China and Europe. The reason that GM, Ford, and others are using the opportunity on high-margin vehicles like SUVs and trucks, they want to make a bunch of money as quickly as they can and put all that into the next generation, which will be electric vehicles. It's very clear where they're going, and they're closing down factories that make the old sedans and the old vehicles because they're not going to have a bunch of guys out there running a stamping press anymore. It's going to be a whole new workforce and a completely different skill set of where we're going. Next slide. Oh, you're there. So the advancement of battery technology is going to be essential to this EV market. The future electrification has a lot of challenges. One of them is, one of the biggest ones right now, is the advancements in battery technology. So we've got a lot of stuff going on here, other than just some lithium-ion batteries that are currently in our, running in the Teslas. We've got solid state. That has a lot of promise. We have graphene polymer cells, laser produced supercapacitors, aluminum air, zinc air batteries. We have a whole range of ion batteries based on different elements: fluoride, magnesium, sodium, carbon. The research is exploding everywhere. And even the major car manufacturers are getting into it. Toyota is putting a whole lot of capital into battery research and new batteries. So because they all anticipate that they're going to be making EVs in the future. Next slide. No, the other way. Okay, so additive. So additive fits into this because additive is changing how they're made and what they're made of. The merging of additive manufacturing and material science together is spawning an entirely new generation of materials and products. In other words, parts are being designed specific in terms of fit, form, and function, and weight to strength ratio, all those, to be printed. They're not being designed to be produced by the traditional production methods. The other thing about additive is, when you really look at it, additive could reduce energy in the production process by 50% and reduces material costs, because you look at that part up there, it looks all spindly and everything. It's just as strong as a block of material for a part being made by machining presses. You're going to reduce costs up to 90%. And you can make, with additive, you can use just about any material. They're making printed kidneys and livers today, and biological substances and matrices. The food products and so forth can be printed. Just about any kind of material. So that's going to open everything up. Next slide. The other piece of this that we have to talk about is generative engineering and additive, and how that's driving a new generation of products. In generative design, you're using a generative process The concept of generative design has been around for decades. But now we can see a real application with additive, when you put this together with additive manufacturing. Because what you can do with generative design is produce parts that it creates the most functional, optimal design that then can be produced by the additive process. So that's the two different, the contrast between the two different parts you see up there. And then the other thing you have to add into the equation is the advanced simulation modeling that is today. The modeling, the simulation platforms we have today where the product designer can completely validate the part before even a prototype has to be made, completely validate it in terms of all of the traditional CAE applications of FEA and all those, and stress and everything. You completely validate that prior to any type of production. What you see here is a prototype type of vehicle that has been produced it's printed, but it's been produced based on the optimal design for strength to weight ratio, and it's generated by a generative design process. Next slide. So industries are going to embrace, going into the future, industries are definitely going to embrace new materials, products, and the manufacturing processes for a competitive edge. It's like somebody said earlier in one of the presentations today, in one of the earlier presentations in one of the workshops about the whole digital transformation, is companies who failed to do a digital transformation and move into these new technologies are doing so at their own peril and at their own existence. The transportation industries will probably be the most affected, the first. Aerospace, automotive, land systems. This is obviously a very futuristic look, but you can bet that Boeing and Airbus and others these are the designs that they're looking at, and they're based on a whole new set of design criteria and materials and processes. You're not only going to have autonomous cars out there with all the sensors and so forth running them, but you're going to have infrastructure built designed to accommodate autonomous transportation. And of course, then you can look at land transportation, hyperloops, all these things that are currently being researched and prototyped as we speak. Next slide, excuse me. So to sort of sum up, science and technology is changing the entire manufacturing business model. Industries are developing products by designing new materials first before they figure out how they want to design the part. Because they can determine what the fit, form, and function of the part is, and hey, let's go design a new material that fits that criteria. Sort of kind of reversing the process a bit. Manufacturers are building factories and production equipments to facilitate these processes. If you go out into a large airplane manufacturer today, you're going to see composite manufacturing in processes that are be completely different from old standard processes of putting together, say, an airplane piece by piece and section by section, so on. So it's happening. And advanced simulation platforms I alluded to earlier, it's going to be completely change the design process. We're already using that. And then the whole digital twin that's actually executed is going to be driving new business models altogether, where companies sell services rather than the product. Next slide. So to kind of sum this whole thing up, science and technology will definitely drive the next age of the new age of manufacturing. The manufacturing of the future, and just to follow up with this last comment, the manufacturing of the future is going to be much, much more than just automation and robotics. It's going to be an interdisciplinary mix of physics, biology, chemistry, and material science. And this is where we're going. So that's all I have to sort of introduce this topic. So what I'd like to do now